Okay, at this point, we can now have our final panel discussion. I think it's sort of a general, as Lauren said, anybody who has comments to any particular questions by the covers, that would be good. Any general feelings or anything specific that you didn't have the ability, that you didn't say before or hadn't thought of before, please bring up. So is there somebody that would like to comment first, or am I going to start with Tom?
Well, I think it's important. I mean, the comments are very useful, and I think we need some time, you know, to digest them a bit and meet with staff. I think I did. There were a couple of comments about setting up a control, and although I mean that sounds very appealing to basically set up a control. I think what that would be very challenging. Is it? You know, it could be another whole study bigger than this one because the controls are so large. I don't even know what a control would be. But I think, I mean, for me, my sense of it, it's not that you need a control, you need something to benchmark the final observations against. And I think because this is an exposure study, it's not that we want to compare the exposure to some other comparable situation, but we want to look at the exposures and the content we know to be harmful. And again, I think that's in the risk assessment plan, but I would suggest that's an important step, is how to make sense of this, because if somebody came in and, you know, told you just ingested, you know, 10 micrograms of zebullium, right, you'd go, you know, what is, I mean, you'd have to know what that substance is and what we know about it, and have a way to benchmark what that means. It might be totally harmless, or it could be the most toxic substance that we've ever known. You'd have to figure something out about. And to me, that's the kind of study this is to really get information about the sort of the absolute measure of exposure, and then get some relative terms in terms of toxicology to make sense of whether there's a level of harm associated with it.
I'm going to touch on a couple of the public comments, mainly, or in these comments. To add on to what Tom said, the issue of what you know from your data is always tricky, isn't it? You can have an endless amount of data and still not know anything. And we've seen that movie before, and we don't want to see it again, you know. And it's not the risk part of it. It's also, well, what's causing this? You know, is what we observe related to the rubber, or, you know, the weather, or what? And I feel that the analytics to allow us to sort that all out is still yet not completely developed and needs focused attention now. A lot of times it's done by hypotheses. You know, you hypothesize this, and then you collect your data and analyze it to answer that question. And I think we're still lacking a little bit of that kind of analytic structure here. And I've mentioned in the sense of, well, maybe we should look at it for some of the fields and figure out what the relationships are at that level. There are other sort of stratified analyses, discussions that we've heard, and collection of data, but it hasn't quite been translated into how are we going to analyze the stratified data to answer a question. So, and there have been some examples of that. So I don't want to belabor that, but to get at this question of, well, what does this mean? What can we conclude? Whether we're not maybe doing a looking at different kinds of fields, but I think there is still some development needed here, and I'm not quite sure who's doing that. So that's something that has been on my mind. I think I commented on this the last time. It still seems to be there. Now, I have two things I want to go back to from the meeting briefly. One is the mercury issue, and the other is this question about the two methods, which are related. Remember that presentation with the graphs that we didn't like? Okay, so I figured out why I really couldn't stand those graphs, because to me, the two methods should be decided based on what question you're trying to answer. Remember the ASTM method and the EPA method? It's not, you can't decide that by comparing the outcome data. It should be decided on, well, are we trying to measure what's in everything in there, what comes out given these parameters in the ASTM method. And so, and I still don't have an answer to that. It seems like that also needs some further thought in light of what we're trying to accomplish here, what's going to be most meaningful to the public, et cetera. So I flag that as something we've talked about before that seems unsettled still. Now, the thing about that, I also want to go back to the mercury. So I looked at the mercury data again, and it's left, well, what should we do about the mercury? And I think that given that the method that's showing the blue dots, or pulls all the stuff out of the sample, is still showing numbers that are environmentally relevant if it were in soil or something like that. I don't see a basis not to continue to look at the mercury, because mercury is a known neurotoxicant that is important for kids. And so maybe there is a basis for, and maybe it's in the realm of someone else on this panel, but I don't see it. So I'll just leave it at that. Okay. And then when we get into this issue about how we approach the risk assessment, that's going to be the hardest part of this probably, right? And that from the beginning. And we're not quite talking about that yet. And maybe we should be. But one thing I would like to suggest at this time for you all to consider before that's all done, when we have our next meeting, is that I think that to address some of the public concerns, there needs to be not only a risk assessment, but also some discussion of, well, what are people getting from this that is separated out, so that they can understand it in two parts, that we've concluded that these chemicals are coming off this stuff in some kind of amounts, and if you're a high user, soccer player, it's this kind of level. If you're a casual user, it's this kind of level. Stop. And then the second question is, well, what do we conclude about the risk, et cetera, which brings in a lot of assumptions and et cetera. And people will interpret that in different ways too. So I'd like to think of that in two stages. Related to that is this question of, are we going to look at cumulative exposures, multiple pollutants, or not? Are we going to consider synergistic effects? And again, we've flagged that as something we haven't decided. And it's still out there to be decided. And I'm going to flag that again, I guess. And then my last point is looking to the future beyond this study. One thing that we don't have is a method for deciding or being able to detect whether these results remain relevant in the future. For whatever collection of materials and fields we looked at now, how will we know if conditions are changing so they're relevant to turf and the crumb rubber in the future? And again, I've raised this. I realize it's sort of out of the scope of OEHHA, but I think we need to think a little bit that way. Maybe it's Calorie Cycle or somebody else needs to monitor whether the conditions that have created what we studied are still true later, whether things have changed. And so there's been some discussion about why we think that the rubber composition will change. And I don't know whether it will or not, but it does seem like that kind of onward-looking, revisiting the conditions that the study was based on would be important to a concern. Unless, of course, we decide there's nothing here. Maybe we'll decide that. So those are my comments. Thank you.
So I only have a few more items to suggest, and maybe a different framework for talking about it. Again, come back to sort of this communication of what this study is about, how it's described, acknowledging both the strengths and limitations of it in a way that is understandable to both the public and the technical community that will review and look at this data. I think there's been a substantial amount of data collected here and or is in the process of being collected. And so there's obviously a lot of work that's gone into this, but I think maybe some of the gaps that I'm still having a little trouble with is trying to connect, and it was touched upon here in various comments throughout the day, what the connection is between the how the data that's been collected and how it's going to be used, how it's going to be connected, sort of from the actual raw data collection, the analysis, through the application of it that will actually lead to a risk assessment. So I think we need to sort of be thinking about, as the data moves forward, communicating what this is in terms of the study, but also what it isn't. what you have and but also acknowledging what some of the limitations of this are, because otherwise you set up for expectations that will be frustrating for a lot of people. There has been talk, and I think it's appropriate that there should be some consideration of synergisms in the data in terms of potential exposures. I think that needs a little bit of thought. It may be that in terms of the analyses and thinking about particularly with regard to the risk assessment looking forward, that understanding or applying what we know or what we think we know about some of these gases, metals, exposures, et cetera, could be informative, because otherwise we may just dismiss individual elements, individuals sort of being relatively unimportant, except in the context of multiple simultaneous exposures and the synergistic opportunities for it. So I acknowledge and applaud the work that's been done. I think there's a lot more work that needs to be done to sort of interpret and analyze and think about how to this data in a way that is both understandable to the technical community and to the public.
On the risk assessment, because I mean, one of the theorems trying to do is to identify some of the compounds that we might not have already studied, and so I'm just not sure what we're doing in the risk assessment in terms of trying to understand some of the toxicity of the compounds that are less, that we know less about, and I didn't know if we were going to use ToxCast or something like that. And then I was just also thinking, and else we don't know, one thing that it seems that I guess we're not doing at all is, and maybe is looking at any sort of non-metals in the rubber. I mean, I guess in a way we're getting compounds that would be semi-volatiles on the playground surface because we're doing wipes, but I didn't know that we were getting any of the non-metal components in the rubber themselves relevant towards the biomonitoring, and I just wanted to comment on that. On the biomarker study, I'm just still concerned that it's going to be really difficult to do that, because I'm just worried that there's not very many unique biomarkers that we're, but I guess once we do the risk assessment and look at the chemicals that we find in the VOCs and so forth, that question will be easier to answer. And then in regard to the controls, I mean, I think the fact that we're looking at the upwind, and I think it was made really clear what the upwind chemical, I think that the panel, the group, you guys are doing a really good job at trying to separate that out, and I think that that's important. And I guess that's all of my additional comments.
Thank you. So I just wanted to sort of echo everyone else on the panel so far that I think this is really great work, and I'm excited to really see the data coming in. I can see the products of this work paying off. Just two broad comments. Again, to help the public understand the study, I think it's important to present sort of the focused research questions and to keep an eye on the prize of these focused research answer with this study at hand, and sort of presenting hypotheses, presenting analysis plans for how we're going to address these hypotheses with the type of data that are being collected. And then just a second comment sort of related to those statistical analyses that will be done. There's a lot of discussion about how were different conditions under which the fields were sampled, different meteorological conditions, placement of the carts in relation to the wind direction of that day. And so I just wanted to encourage, thinking of more sophisticated multivariate models rather than most of the bivariate models that we looked at today, to some, if we're pooling data across fields to account for these differences in conditions and to address these targeted questions.
Okay. First of all, I think you guys are, oh, okay.
I'll just confuse it and come back in. There is one more comment I forgot to mention. I know. I didn't want to preempt you.
You'll get that.
And that is on the area of PM 2.5. I mean, I think there was a lot of data that's presented. There's a lot of data that will be done. It's important to note that PM 2.5 is both a regional and local, has regional and local impacts. It is considered a regional pollutant, and so some of the issues in terms of thinking about it and separating out what the local contribution is a challenge. But we know from other health studies that there are both regional and local contributions, and so it's not surprising why we see in what seem like clean areas that we see effects, and sometimes those effects are equivalent to what we see in dirty areas. And again, it raises the issues of how we define the terms and use them. So I would just encourage you to think about this aspect of focus on PM2.5 because of the regulatory implications of it. But I think that it's important to sort of think about how we identify and assign value and importance of it in the collection.
Okay. First of all, I want to say that you guys have worked really hard and done a very good job. Having done a lot of this myself, I know how hard it is, and I do think you're doing a great job. Listening to the comments from the people that commented and also the questions and the comments we've had, I think one of the things you need to do next is develop your exposure modeling framework that you're going to use. How are you going to model this? And really, I do think that you need to do some kind of probabilistic model that allows the range of the data to be able to estimate what are the percentages of exposure, be able to give information on the uncertainty. So you've got a modeling framework to fit your data in. And then it becomes what data you need, what kind of data you're going to need, and how you're going to input it. And I think that when you do this, the other thing that you have to consider is the exposure routes, because different chemicals will have different toxicities depending upon the route exposed to. For one time I was doing styrene and looking at it through ingestion, and one of our dose modelers says, yeah, but you know, that's immediately detoxified in the liver or something. So it's not the same as inhaling it. And so I think that people need to understand that a PAH that is nearly as toxic as a PAH is inhaled. And I think our models need to take that into account. So again, I think the first thing you need to do is start to look at how you're going to model what data you need and how you're going to put it together, because I think that's what's missing right now. I'm planning on doing the modeling, but I think now's the time to do it. I think that the other thing is that you need to think about, you know, once you have your results, how are you going to verify that you've gotten someplace close to the truth? And I think that, you know, again, if you can do it with biomonitoring, that's great. That's always a hard thing, but is there another, you know, if not, is there another way? Because you've done all of this modeling, but how are you going to give confidence in the way that you've pulled it all together? That's why I wouldn't even call it a biomonitoring study. I would probably call it a verification study of whatever it needs to be, because that's what people want to be able to see. I think that there is, you know, this question of how are we distinguish between what is tired crumb, what are other components of what's being manufactured, and what is just part of the environment. And I think that, again, one needs to look at, I mean, we had some discussions today about when you're doing your analysis, can you do sort of, or, you know, you can take your material and you can do outgassing and you can fingerprint from that or something. But again, I think that that's one of those questions that everybody has. How do you develop controls, or how do you really demonstrate that it is from tire crumb? And then I do think that you need to put that of some other environmental exposures. I mean, I did a lot of kids' exposures in homes, and house dust in homes, one would believe is deadly to all children. It's not, but there are just a lot of pollutants in house dust in homes. So again, I think that that needs to be the context that looked at there. But I think those are the important things as you move forward and start thinking of the way that you pull the data together and make people feel comfortable with the way that you are pulling it together and how you're thinking about it. So that's really my comments. Anybody else want to have another round? Okay, I hand it over to Lauren.
Well, let me, before I say some huge thank yous, let me ask Patty to say a few words about the transcript and the posting of that, and the posting of the slides and what the next steps are for that so that the public knows how they can.
The meeting is webcast, as we know. It's also audio and video recorded. And the recording will send to a certified court reporter. We will have the transcription post on the website once it's fully certified. And also we will post the video like we for the YouTube, and the link will be on our website. And we will post all the slides that we present today. We have to format it for a accessibility reading. So give us some time. We will work on it, and it will be on our website. Also, we will collect that we received today, and maybe the end of the day, and we will put it on our website, and we will discuss internally and provide as much as we can response to those comments. These are all going to be on our website for public.
Thanks very much. So this has been a really fruitful meeting. You've given us a tremendous amount to think about and to think forward on what our next steps are. I think coming out of the last meeting, we had a pretty long incorporating some of the input into our next steps. And I think this meeting, we have a bigger list. So I do want to, so I do want to thank everyone, including the panel certainly, as well as the public for what we received. You've given us a tremendous amount to think about and work with coming up, and I think also John Baum's as well.
Even though I played hooky.
Yeah. So thank you, everyone, and I do want to make a special thanks to the staff, to the lab, and to UC Berkeley and University of Arizona. I don't think I've forgotten anyone, have I, Patty?
All the other help we recruit from OEHHA.
And all the other help from OEHHA and our lead. So thank you all so much for all the hard work, for having such a rich meeting, and it will only improve. I think we may, in fact, I don't want to make any commitments, but I would envision that we might be meeting in less than one meeting as we follow through on your comments and put together a framework and a structure to discuss in terms of our exposure as well as risk assessment. So thank you all, and we're 2 minutes early, so very good. Oh, and John, did you have any closing remarks?
Well, I do want to thank staff and panel members and the public commenters that I didn't hear, but I guess there will be a record so I can look at it. I was next door at the California Resources Board where we had a big, we had a lot of discussion about how to spend settlement mitigation funds, and I couldn't miss that. But anyway, thanks for your patience with me going in and out, and I'm sure the panel did its job without me.
Meeting is adjourned. Thank you.